So how do we start the journey? How do we start a cybersecurity journey? I know what it feels like now. We talk about all the risks. There are a lot of risks that automation systems face. Um, it seems like a one against many, that there are too many possible attacks. So where do we start? Because at the beginning, it feels like this. It feels like we have a huge system. We're supposed to protect it, but we don't know exactly what we have. We don't know exactly what the risks are. It's almost an overwhelming task. Now, what the government did based on that exponential rise that you're seeing and the need to protect their critical systems, but also manufacturing in the United States as well. In 2013, it issued an executive order to improve the critical infrastructure of our essential manufacturing environments and a lot of the essential government services. What this charge was the National Institute of Standards and Technology, or NIST, to lead a development for a framework for manufacturers to follow to secure their systems. This wasn't the original one. There are other standards out there, but this is a framework that manufacturers can follow for securing their systems. This is an overview. So what the framework does, it's not a checklist. It's more of a guideline for when you're building your program, or areas to address to make sure that you have a plan in place. So we look at the main functions: identify, protect, detect, respond, and recover. It's similar to what we've talked about. The before, we identify what we have, we protect it. During, we detect what's going on and we respond, and afterwards we recover. So these are built into the framework. And step one, I guess what we would say, is to identify what we have. So when we begin to make a plan for ourselves, and I've seen this done multiple ways. I'm going to show a spreadsheet in a second that'll actually highlight all of these categories in a bit more detail. But here are some examples when we're making a plan. So one of the subcategories, physical devices and systems within the organization, are inventoried. So before we can even start to secure our system, when we start looking at that, the picture we showed earlier with all the cables and just the mess of a system, if we just take an inventory of what we have, we understand exactly what we have in our facility, in our plant, we can actually divide, we can get that segmentation back that we've lost over time, so we can actually protect ourselves, we can segment our networks into the areas that need to talk to each other. We can understand where our vulnerabilities are based on what we have. And then we can have a response plan and a recovery plan. Now, the key parts of this is that they both include a plan. So we're not going to react to something after it's already happened. We have a plan in place for exactly what steps we would have to respond and recover from an event. So this is where I say it's not a checklist, it's more of a guideline to make sure you're covering and addressing each of these issues overall. Now, what we looked at was a simplified version. There are the functions we talked about: identify, protect, detect, respond, recover. And then there are categories, 23 categories. But within those categories are subcategories. So when we're talking about identifying the systems, identifying the software we're using, how should devices be talking within the system? The framework itself wasn't writing all of this from scratch. The framework is a guideline that's built on other standards. So a common one, ISA 62443. There are some additional NIST certifications or standards it follows. But this is just a consolidation of these other standards into a single framework that we can follow. This is ISA 62443. We're not going to cover it in quite as much detail, but I do want to highlight a few things on it because it's another common standard. So we protect our products, the individual products in the automation system. We protect the system itself. We have policies, and then there's some general categories built into just the overarching implementation of the standard. So it's layers of protection. So the product protection, that's something that Rockwell does. Rockwell actually has certifications for ISA 62443 for their products. something like 2-4, those are installation and maintenance guidelines. This would apply to integrators or someone delivering the installation of the system. And then the system security, so 3-3, this is a combination between the owners and the integrators on how to ensure that their system is secure. So the cybersecurity framework published by NIST is a guideline. 62443 is a way to measure how you're doing against that guideline. It has levels of security. You can actually monitor your success against what it expects you to have. And that's going to compare it to, is it somebody that an internal person accidentally made a mistake, to a hacker that's just doing a general attack, to a sophisticated hacker, and finally a nation state, somebody that's very targeted, very heavily going after your industry. That's going to have different potential industries that it would go after. So 62443 is a way of measuring how protected you are against something like that. Are you protected from something accidentally happening? To, are you protected against the nation state? Now, the investment against the nation state is going to be much higher than somebody accidentally making a mistake. So there's going to be some give and take as far as how far you should go with that. But what we'll focus on is that framework. So we're going to talk about step one. How do we take this mess and identify it? We talked about how to physically inventory our assets. What we want to do is we want to take this and turn it into something like this, something that we can understand, something that starts to make sense. We start laying out a picture. We identify exactly what we have. If we break it into levels, if we know exactly what's communicating, that's even better, but we have to know exactly what we have. Once we know that, we find a little bit more information about it. So in this example, I'm going to show some Rockwell automation products. So we've got a processor, a 1756L61, an Ethernet module, and what we want to show with these is a few things. One is the model, and the other is the firmware that it's on. So once we start understanding not only what we have, but exactly what it's running, and some of the additional information that gives us context about the device, there are actually published standards on this. So you may have seen these come from Rockwell. Whenever there's a vulnerability announced, it's published within a database. So this database has vulnerabilities listing all these advisories that it finds for manufacturing equipment. So one of these, for example, this is just an Automation Direct product that's actually highlighting an issue and what products are affected. So if you see at the very bottom, the versions that are affected are firmware versions prior to 6.53, meaning that if we go beyond that, we can actually protect ourselves. So why it's important to understand firmware in the additional context is to know where we're affected and can we protect ourselves. We're actually going to take a step over here now to this site. This is where the link will take you. Current advisories for products. Like I said, it's a lot of manufacturing products. We'll pick on Rockwell here for a second. So it notes one here about Rockwell Automation RS-Sync Classic. If we click on this, it's going to give us an overview of the vulnerability. So an authenticated local attacker could modify a registry key, lead to execution of malicious code. It'll give more details. It'll tell who found it, so how they found it. So fortunately, there are good hackers and there are bad hackers. Fortunately, the good hackers, white hat, find vulnerabilities like this when they're doing research and actually publish this information so that the manufacturers can go in and resolve the issues. So this is where a lot of patches come from. They find a vulnerability, they go out and they fix it. And what it actually will provide within this is mitigation steps. So if you're using these versions, then to apply this patch. So it tells us exactly what steps we have to make to protect ourselves. Now granted, doing it this way in the manual fashion would be a lot of work, but the information is there to go ahead and protect ourselves. And this is just back part of the framework, understanding what our risks are and understanding where our vulnerabilities are. So let's talk about how an attack happens. So what we know so far, we know exactly what we have and we know what our vulnerabilities are. So a cyber attack is really someone or something using a way to get into your plant and expose a vulnerability. So devices have vulnerabilities. Throughout the process, obviously manufacturers are trying to eliminate as many as possible, but they're still out there, they still happen. They patch them when they find them, But while they're available, while they're exposed vulnerabilities, zero-day vulnerabilities is another term for it, where there's not yet a fix. The way the attack happens is someone follows a route to expose a weakness. So when we understand what our vulnerabilities are, what we have to start thinking about is how could they be attacked? So who would do it and what route would they take? Is it an insider? Is it somebody that's disgruntled? Is it a low to mid-level hacker, or is it the foreign nation state we talked about? And how are they going to get there? So a hacker would have much more chance of reaching via the internet. But an insider could actually affect it from the local plant or even inside the facility. And this can happen with the others as well, with more sophistication and lack of security, physical security within the plant. So we have to think about, when we're protecting ourselves, who would attack the system and how would they do it? And then finally, what impact is it going to have on our system? Is it going to shut us down? Is it going to be relatively minor? There are customers that have gone down for months with cyber attacks. It's wiped out all of the Windows machines on the network. So something that critical is going to have a huge impact. In what industry are we in? I mean, critical infrastructure. For example, right now, food and bev, pharmaceutical, based on the current pandemic situation, are extremely essential businesses to keeping the US going. So if something happens to these industries, whether it's even in a pandemic situation or during normal operations, these are going to have a high impact on the supply chain. And what that's going to dictate is, once we understand what the impact is, what steps do we have to take to protect ourselves? The higher the impact, the worse the event, the more it's worth investing in protecting the equipment. And these are all going back to the guidelines built within the framework. Here's some examples. This is from the NIST guidelines. So once we understand what the impact is, we can start applying these baselines to our system. And what you see is the low, moderate, and high. The moderate and the high systems are going to have more steps they need to take to make sure they're protected, including simulated events and automated training events. So something like penetration testing, where you're going to actually simulate a cyber attack and make sure that you can detect and respond to the event as it's happening, would be something required in more of the high level, but not necessarily every customer would need to have. And that's an important concept for cybersecurity overall, is once you become a cyber aware customer, it doesn't mean that you're going to implement every single patch that comes out or take every possible step you can. It means that you are understanding what your system has, what its vulnerabilities are, to know whether you need to implement or not. If you have a system that is isolated, then you don't have to quite put the same protections in that someone who's got it in a more exposed internet-facing type environment would. Or if you were protecting yourself from certain protocols coming across the network via other methods, then you can actually continue to run without a patch because you have a higher level of protection. So when we really start understanding this cybersecurity journey, it's understanding what steps we specifically have to take for our system.